Okay, so today our objective will be we are going to uh, complete the as I last class discussed, we are going to understand how we can create new threads or how we can run our set of code in separate thread as a concurrently as a asynchronously, right? So today we are going to understand the concept of completable future. Okay, completable future,
Right.
which also help us to meet the some special use case of our application. Till now, notice whatever the uh, we have understand this is my code and I want this code run by the separate thread. So the particular code I written in the particular method, and method can be no return value or can no take any input value, right? As of now, and study we also see might be some threads can return some value as well as, right? So there is a situation we are going to create threads. One thread, just this is the separate thread. This is our main threads. From main threads, I started new threads, and new threads doing some work, and after that they are not returning any value. One possible cases, okay. And second study says, okay, sometime I created new thread, they execute something, they do the business processing separate thread, and after that they return some value as well as. We also understand this is the by runnable interface and this is by callable interface. But sometime our situation scenario can be occur. Let's say I created one more threads, okay, and they say ki whatever the output of these threads, I want to pass to these threads. Whatever the output of these threads, I can pass to this thread. Okay, that means our this code can take some input, right? So scenario we are going to understand this completable future help us to make a communication across the request response kind of things. One thread doing something and get the response here. Again thread take input and do something and again give back to the next thread. So look like a sequential programming, but really they run the separate threads. So good case example. Sometime nowadays in the era of microservices, you notice our application generally build on the different microservice. One microservice can be let's user profile microservice, right? One can be user detail users credit card, user credit details score, user maybe user transaction details. If the different microservice we have, the sometime I'm going to call this microservice and getting some response. This response might we have to pass here to check the customer credit details. Might be same response I pass here, figure out all the transaction detail of the customer. So in this case, if you're talking about the sequential programming, similarly, simply one thread go call here, get back, get response again call here, get response again call back here in this way. So by default, one threads can do, but it will take some extra time unnecessary. This is the different microservice can be do independently, can be do independently, can be do independently. Then why our main threads are our requested threads are waiting. So our purpose is that we are going to create this is separate thread, this is separate thread, and this is separate thread. They are going to start at parallelly, they are going to run, but whenever this thread completed, they give our input to this thread. Once this thread completed, they give our input to this thread. In this way, chain of request response we can uh, achieve in this case of your multi-threading as well as. And one major you can say problem you notice yesterday, whenever we can started one thread like callable threads and that's do some processing and then return value. So you notice started we return the future object, okay, future object. And if you want to get value, you say future dot get. So whenever you dot call get is the blocking call. That means here our threads are waiting until this thread is not completed the jobs and return the value. So here you can say this is the blocking call. Means ki our application, main application, or requester application just waiting for you to complete. Once you complete, then I'll continue. So this is known as a asynchronous blocking call. You are doing multi-threading, still you are blocking for some situation for getting value. So this hurdle is taken care by completable future. Say, hey, completable future, you want to get value? Why you are waiting to someone complete? Why not just reverse the possibility? Say, this is my code. Here I want to output. Whenever you complete, you can write the data here. Why I am waiting for your response? Why not I reverse the responsibility? I say, you are the threads, you have to return something. Okay, I started. Once you completed these things, then you can just call me, give me data. I'm not waiting you, just you give me data whenever you complete it, right? So this is two way. One way ki I am waiting for your response. That is the future.get method. We started get example. As a threads, I am waiting my child thread complete, then I get the data. Second way, no, I am not waiting. I just tell you when my child thread completed, they itself give us the control. Hey, I am completed, you take data. So whatever I am doing, they inform me, hey, you now you can get data. You can get the data. So here our major objective, we are going to avoid blocking call. Avoid blocking call. Or you can say computer feature support non-blocking call. Non-blocking call as well as. So these are the some key additional concept or feature this completable feature give us. With basic things like multi-threading properly we can understand, we can get from the runnable interface, from the completable feature base. Okay, but both a runnable interface or completable feature callable interface, both have a only problem. This runnable interface are not returning any value, that not taking any input. That means whenever I can start my threads, they started, but whatever they are executing. They are not returning any value, and even they are not taking any input from you. So this is the, you can say, some design constraints of the runnable interface. So whenever you are going to start thread by this syntax, means your code where no return value and no take input value, if such business requirement, this could might be this is helpful whenever you are starting these threads. They are going to, after doing some processing, and they are just updating some database, updating our information in the file system, maybe reading data from the some file systems, where this system internally going to take input from the other resources and also informing to the other resources. There is no any communication from where the particular thread is started, right? So in this case scenario, this runnable interface implemented threads are helpful. But sometimes this is a callable. Callable have a problems. Callable have a good option. Ki, let's say this is our main application. Are requested, you can start new thread. New thread is started. They are doing processing. Now they can return back to some value. This is the one option, very good. But still, these methods are not any expecting. This thread want to pass some input to you here. You cannot pass because the callable method is not expecting any kind of input. So there are some challenges, or you can say use cases. Different use case, different tool you have.
Then
In
how
the
can
such
you use that with return and the parameter?
same we are going to discuss.
Okay.
Till now, whatever we had discussed, they have different use case. They are fit, they are work fine, right? There is no problem. But in the sometime our business application have some requirement. I have some input and output both, right? Those code I want to run from multi-threading. Like, let's example, I have a static void method return integer value, and let's key there's some calculate calculate calculate, and they take some input value, right? Whatever input, and they are after doing some calculation. Let's the integer calculation equal to some, let's say calculation plus they are adding 10 number, right? And then return your uh, calculation. Might be case. So if you want this code should be run in the multi-threaded environment, till now we have not any. What is this? Okay. Such code I cannot call from your multi-threaded environment because there is till now I have not studied, right? But possible. Whatever the code till study we understand the method does not return any value. Okay, method no return value, no return value. Okay, we already did. We can call it from here, right? Something we can return, right? And might be some cases method even return some value. This is the this is no return value, means they have not written any value, right? No return value, no return value, no input, no input. Such method we can, this means just you have to only option just print something, right? Do something and as out print something, right? This is some method with the return value but no input, no input, right? So here you are not passing, here you are not passing input versus return value something, right? So now
Right.
here can, instead of printing something, even I can return some value as well as. So till now we have covered this scenario. This method surely we can call in the separate thread, right? Okay, and just say yes out. This call dot, just know the different. Okay, this is the way, the way. This is the way. So just say in the method name. Here method name could be like uh, return value with input. Okay. So now today we are going to some requirement scenario. This here I also want this code run in the separate thread, right?
Right.
So till now we have a good option. We know how to do this. How this do from the runnable interface, because the same syntax runnable interface syntax, they no input, no value return, right? This is
Right.
the code I can run from the multi-threading. Similarly, callable have option return value but no input. You can do from this syntax. But
Right.
till now, how I am going to run this code in the my separate thread? Okay, so let us think. Okay, till now any confusion? What we are going to understand, right?
I understand
So
now.
lots of this completable feature have benefit, but this is a one benefit where you can call any kind of methods in the multiple thread. Even not just only this limitation. Any kind of methods code you want to run as a separate thread, use the callable interface. Callable interface is designed very generic. You decide what kind of input by one argument, two argument, 10 argument, whatever they are, right? All the things you can call from this, you can run your code in a separate thread, right? So let's first understand how we can going to achieve. These two you don't have any problem, right? Because this is very simple. Uh, if you want to this, so let's say if you want to this call, no input, no output, simply say new thread and here you can pass sample dot reference and dot start, right? This is a simple way.
Right.
So they can return because they are not taking any input, they were not passing any input. If we not return any value, they are not returning any value. Okay, so till now it's okay. But sometime no, I want to return some value. The status say you have to use the future object, right? Notice this method call and print something, right?
Right.
And I want to call this one where you have to pass not anything but get some value, right? So how to do? Surely you say new thread. Notice you're trying to call this method like this one. You say sample dot this and start. So notice it will work. But question is that this method return value where I can get value, right? Because
Right.
this method start method and this method not any return value. But I want return value. You can call this code, but they are not returning. I'm not able to notice both are called, right? But I'm not able to get value. For get value sake, you need a future object. So you say, hey, uh, notice I'm not going to call this because this is the way run, but I am not able to get value in my main thread. The you can do, but preferable way you can want to this value as well. What they're returning. So instead we say you can use a future object, right? So you can concept here you have two options. You can use like a completable future where you can submit, or you can use even thread class. Notice we have a one constructor which accept future task. Uh, let's look the constructor. Oh, sorry. Go there here and look the constructor. Constructor. Oh, how to check? Go to inside the class. And notice here, let's check the constructor, all the constructor. So notice here, lots of constructor this thread class defined, right?
Right.
Thread class have lots of overloaded constructor. So we have used runnable, how to pass. You know runnable with the name of the thread. But notice here somehow, uh, thread group, there would be some return value. How to return? How to return? No, it's so strange. There would be something constructor boolean value. Somehow I can pass. I have remember one is a concept future task. Future future task. It's the future task. Future task. They have a runnable future. Okay, good. So future task equal to the new future task. And here I can say what future task say. You can pass callable runnable. Notice here, I can pass any callable or runnable. So here callable means a method that returns some value. So I can call this method. They return value, right?
Right.
So here simple dot method with the return value. This one. Okay. Right? They want to check exception. Try catch. Null point exception. Okay, let's throw exception here, right? Throw exception. And right. And now here future task you can pass here, right? Notice they are accept future task, right? Because future task accept because they are runnable. Look like notice future task is a runnable option. They have a runnable feature. A runnable feature internally implement your runnable interface, right?
Right.
So you can we have a two-way. We can one with the future. Now you can start, and after that you can say, hey future task dot get my value. Okay, out. Here you are getting the output from this future object. You are saying, hey thread, start this, but I want to get the value. So here I am waiting to getting the value, right? So in this way you can get value. But here notice the problem. Our thread is wait. Now it is getting value, right?
Right.
So in this way, this is the one way. You can call, or you can start to say you can use a try block with a completable future, right? So here say executor, executor, future service uh, equal to executors here, and here you can say dot submit. And submit, notice they have received the callable or runnable. Runnable means no input, no output. Callable means return value, no input, right? So here I can pass my this. Okay. So here say submit, and I can pass my method. Okay. They return with a future object. Dot future. And now you say future dot get. Finally, you have to get the output get. So this feature dot get written with a, you can write this way, or you can write this way whenever you want get output from your separate thread. The two way we have, but both have a value. Notice both I'm getting the value, right? So now today, uh, let's how I can pass this input here. Do notice here I can, let's here I am trying to say, hey, I am going to uh, pass some input, because whatever thread return this value. So they have a not any option, because this submit method only accept callable or runnable. Both interface are not expecting any kind of input you can pass, right? So this is the
Right.
problem. So completable future is think something differently. Till now, it's okay. This is the previous way, whatever runnable, callable we are doing, right? There is no
Right.
problem. So now let's comment out. I'll come to the comment. And now let's look the completable future. Completable, completable future, similar behavior type. Completable future, you can say, I want to dot. Lots of this class method we're going to discuss in the multiple classes. But as of now, let's say completable future say you want to uh, uh, complete, and notice here they are expecting something. Okay, let's say simple way. First, notice completable future is first things, let's under this is the class. You can create the object, right? But how I can going to create the object? Flat using the new, or how? Is it possible or not? Let's try. Let's try to create completable future using the new in this way. So notice it's done. But question is that what they are doing? Question until our objective, hey, you run my this code, right? This code in a multi-threaded. They take some input, they return some output. So surely they have, if you run, it's work, there is no problem. Here, if you run this code fine, but this is not doing anything, right? Because as a programmer, we are not passing anything, right? So how to pass something? So someone say, don't use this. Already I have given some factory method to create this object. So don't do this way. You say, hey, completable future, I want to uh, run in the multi-threaded environment. So say run, and run. So notice here they have a multiple overloaded constructors. So I am going to talk about this supply async. Means we are going to run code asynchronously. And let's understand what this interface expect. This interface expect pass me supplier. A supplier is also one kind of interface as a functional interface. They are getting some value from anywhere. Okay, look like, notice they are also not getting any input but return something, right? So here completable future what design say, this in this code, whatever you can write here and call this way and this way, and let's first explain you what is supplier interface. These methods are expecting supplier interface. Okay, so supplier interface. Let's see, this method you want to return integer value. So here you can say I want to run integer. Okay, that's great. Let's create supplier. So notice this is a functional interface. Functional interface I can implement by the different way. Implementation class, by a anonymous, by a lambda method, by a method reference, anything, right? So let us, as I am just creating the method reference. I calling here and say call my method this return value something. This is, and here I can pass any 10 value, right? So in this way you can create supplier. I just supplier here pass you. What you are doing, you are just using the method reference lambda expression, and here you can call any method and pass any value that return the result as well as.
Because it's an interface. That's why you put lambda.
Yeah, this is lambda interface, functional interface. So I
Hmm.
can use the lambda expression, right?
Right, right,
So here say you can write code this way, or flatly you can say dot supply async and directly call this code here itself, right?
oh, okay, okay,
Both are the same thing, right? Let's say
right.
pass one, right? Question is, I'm calling this, so is work is done my work or not? Okay, let's say
Right,
comment out. I comment out. So let's run. Is question is that where they return value? How I can get value? Surely you are able to call, but we are returning some value. Whatever the input pass plus 10, I am returning value, right?
right,
So let's just run. Let's just run. So notice I'm not getting any output. So
right.
what? Because whenever this going to start new thread, until after that main is going to complete it, right? So I'm
Right.
saying, hey, main, just little bit wait. Our our second option, they return the variable. Let's return the value. Notice they return the completable future object. Okay, they return the completable. Here say completable future dot get. I want to get value. So here I am trying to say, hey, I want to get value means here our main application is going to wait for you to give value, right? So whenever
Right.
you wait, at that time they return value. There is no problem. But question is that here I don't want to any kind. Notice I am getting value, right? Because you are explicitly waiting to get result, right?
Right.
Okay. So any other way without get I can get the value here. So this is the my main thread. Main thread requested, hey, start new thread. New threads do some computation and want to return value, right? So
Right.
why not I say ki to one way ki I am say here get method. I am getting your response. Another way say ki no, I'm not going to block myself. I'm interested to other work, right? I'm waiting for result. I don't know ki when you are going to complete your task. Maybe you are in a loop. Maybe you are a waiting stage, right?
Right.
I'm saying, hey, I'm going to start you. Once you done, you can let's go new threads and give those your return to the new threads. And new threads started and going to print the result.
Okay.
So, so here I'm what I'm saying. I'm just responsibility. I'm going to start you, and after starting, I also give you hint. Once you done whatever result, just get the this is my new threads and give your result here. And my
Right.
result, new threads get the input and whatever they want to printing, processing, they can do, right? So
Right.
in this way, I am not waiting for you. I am going to do my continue next work.
Right.
So here, this blocking call, we are going to avoid just associating some new thread to here. Hey, just informing this thread ki once you done, your thread call go to the here, something different place. Just you call me. I'm not waiting for you. The question is how I can associate this concept, right?
Right.
So here say I am not, let's here say main thread is out, main thread is doing something. Just say main is doing one, two, the whatever the main have work. Main doing own work. Doing code own work. Work. Okay, one. And doing work. And after maybe after a couple of seconds, let's see. Just I'm instead of writing multiple code, just say ki main is doing something. Now let's wait for the 3 seconds. Okay. So here, if you note, I run this code. After this code, this is not I'm getting output, right? Because two, that's three, and but until you're not getting, we cannot continue here, right?
Right.
So we notice here, while getting this output, and then we're going to 1, 2, 3, right? So what I can do? No, clearly I'm not interested to call this. Wait. So this is your completable future. Say ki once this completed the output, then you say then I want to just print them. So just say print whatever your result, okay, result. Give me what I'm going to system dot out dot. Yes, as of now, okay, let's see. I'm writing something and just I'm printing your value result equal to result. Here what you say, here you cannot got dot call get. You say then accept whenever this task is completed. Okay? Whatever you doing here, okay? Once whenever this task completed, whatever the result you getting, after then you can go to do this work, right? So this is the method then accept. Here just I am associating one code. Once this thread is completed its job, they are going to the call this method. So this is known as a look like you are telling this thread whatever you're doing. Once your work is done, just call this thread, getting your input and do something. Let us run this. Okay, I am missing something. Okay, this is not required. Yeah, that was never. So notice here our main thread is going to steal our work, and after that you are getting a result, right?
Right.
Is result given by one from this different thread pool, not the main thread. Main thread is not getting a route, right? So
And
this is
how did you run this thread, the new thread?
just I'm not saying, I'm just telling, hey, complete your future. You are going to once complete, then this is the method I'm using, then accept. And then accept check whatever the result you are receiving from this thread, whatever result you are resulting returned here, and after that do some processing here, right?
Right. Right.
Just printing, just want to print the result. So in this case, this the blocking call we are going to avoid with the non-blocking. Just I'm not waiting for you. Whenever you done your work, then you do this, right?
Right.
So here, what we are doing, whenever our main threads are say, hey, thread start, new thread is started, they are doing his processing. And after that, once you've done your work, I associated some code, then do print your result here, right? So
Right.
here, main is free to work our own work, right? Even good option, this result, you can say, hey, I want to maybe some another processing, and this result go to the another processing. Multiple threading here can be. Here say, yeah, whatever the result call here, and this is the input, and do some processing. You also can return some the value and pass to the another one, right?
Mm.
So this is the multiple thread, multiple thread, multiple thread. You can start, and one input pass to another output, another input pass to another output, right?
Right.
So let's key here. I'm just currently the accept method, only the print the result. But notice, if you want, after that again you do something on the basis of result. You are doing some action, right? You want this return value. So according to your concept, you have to do. So let us. You have just generate the scenario. So in this completable future given tons of helping method, right? So today we are going to just understand one or two, and couple of more classes we are going to understand other classes. They have given the, because whenever we are going to write in multi-threading, different use case, different scenario occur, right? For all
Right.
scenarios we have to take in care. So this
So
completable
in
API,
this scenario,
uh,
we also have to use this in different scenario as per the
yes,
business needs.
yes,
Like this is
yeah,
also, yeah.
yeah. So let us here. Even you don't write this variable, even you can write one liner. Here say, okay, this is the completable future dot supply async, and here say, ki this is arrow lambda expression. Here you can call any method that return value. So I'm going to call my method that take value. I can just say, ki this is the my uh, mm, 99 value, and once this thread done work, and after then say, then whenever say accept means just you want to print, then apply means you want to again do some processing. Then apply, let's key whatever the result I am get from the thread one previous result. I am say here I am going to call the same method again. Let's maybe some different input. So I can, you can even call same method your result, right? Even you can do any number of chaining here, right?
Right.
In the result, whatever. So whatever this thread return output, this is the input, and this pass the here as input. Notice this method take as in. Oh,
Right.
uh, then accept, accept, then apply, again call, and after that you can say after that again then apply again. Accept. Here after that I want to just print the output, right? Whatever the result, final
Right.
result. So what say? Okay, method name I pass galat है. Let's say not in this. What this error say? Structured semicolon. That's yes. So here what are saying? We are saying, hey, completable future. First, run this code in a different thread. Whatever the output get, let's do the another processing, and after that again do just print them. So in this way, you can make chain request response request response request response. Here we are not going any blocking call. Just we say, hey, this is a separate thread, this is separate thread, and this is separate thread. And this is the way you can design your application business logic, right?
So what is the example why I need to use this? Like what type of question?
Let's say
Right.
I'm giving some example.
Okay. Okay.
So notice uh, I am getting output like 119. Why? Because here I passed 99, right? Input
Mm-hmm.
99 pass, 1919 go here, add 10. Then what become? 109,
90.
right?
Yeah.
Because 1999 plus 10, that means 100, right?
Yeah.
9. And after that, what you say? Again, what my question is here, you are again calling this method, and let's see, I print this value input. What you are returning value? Again, you add plus. So here say plus x, right? What the value you receive, right?
Right.
Whenever someone this call method, I print the x input, whatever the value. This is the your input, and whatever the value, I'm going to just add plus and 10 and return, right? And just
Right.
run. Just we took this the output. So notice whenever your 99 pass, then you value again next time call 109, and then you return plus 10 90, right?
Right.
In this way you can get different value. So question is that this scenario, instead of method one method two, let's some basic example, right? It's more clear. So here the objective is that now our multi-threadings, our thread, all threads are going run independently without interfering other one, right? Here our main thread just started you, and you do your logic. Let's this thread doing something, and whatever the output just pass here, this thread doing something, whatever the output they pass here, this thread doing something, whatever your output pass something. So in this way your main thread is free to do whatever they want to do, right? So
Right.
here the waiting and notification things you are just removing. You are not going to wait other summer. So what happen if you're not implementing this? That means your main thread start this thread one. Work once this waiting, once getting a result, then I can another thread, right? I say
Right.
hey output. Once this done, I'm again have to wait, again call the new threads and do the business logic, right? So our main threads are waiting to completion of this, and this, right? So what I say, no, don't complete. You just start thread, and after that you forget. We will do internally. Once my thread is done, I give output to another threads. Once my input done, I give my output to another threads. So this is the way you can meet the business. Okay, let's some use case. Okay, here multiple use case might be, maybe some microservices related, or maybe some mathematical calculation related, maybe some transactional related, right? Might be case multiple work are dependent to each other, right? Sometime. Okay, so let us example, we are writing some scenario. Let's mathematical calculation is good. So first my method static, first my method say hey, uh, get 10 number, right? Get 10 number. So I say hey method that return the maybe list of 10 number. Okay, list of integer, uh, generate number, get generate numbers, generate 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 numbers. Okay, yes, they are first my method. They generate number. They are not taking input but just return some value, right? This is the one case. What they are doing, sir, int stream dot close range. Let's give 1 to 10 number. I generated and list. Okay, okay, box to list. Okay, this is the they return 10 number, right? Okay, the first method you may call generate number, right? The first use case. I'm first going to call my generate number. They generate 10 number, 1 to 10 example, right? And after that, I'm going to double all the number, right? So let us going to write another method that say double the number it, double it's right. And they take this input as a parameter, right? What is the input we receive, right? List. So how to double it? And I'm going to double it. So how to I'm going to double it? We have a list. So I'm going to stream, and after that say, hey stream, map them, and whatever the number you have, just number multiply by 2, right? And after that say, hey to list return. So I'm going to return double it, right? Yeah. So this is my business logic, right? So one thread's responsibility to generate 10 number. Second thread responsibility to double it. And let's keep third thread, just sum of them, right? Thread is whatever the number you have, I am going to sum it or sum it. Okay? And after the sum, they return the one integer value, right? Sum have a one integer value. Retrieve all the value, and then I'm going to the sum it. So how to sum it? You know already how to sum it. We have a list dot stream dot uh, sum. I think sum.
No, it's stream. Then we use
Sum it. Now I have to list of number. I am going to stream them, and after that I am going to reduce or
filter.
filter. Just filtering, counting. Don't limit some. Let's keep map to integer, and whatever the input I pass input here, and I want to just by default sum function. Yeah, this is the sum function. First I have to convert the integer object, then return. Okay. And I am going to sum it. Okay. This is the sum it function. Okay. We returning here now three function. So one way we can sequentially call this, this, and this. I'm get the output, right? So one simple way without multi-threading, right? So I'll comment out all the thing, right?
Right.
Comment out, no multi-threading. Okay, if I'm going to simple, say main thread, call the generate number, they return some value, right? Numbers, and here you see the numbers. And after the once number generated, I am going to double it and pass the name input, right? Whatever the number we have.
Right.
They return some value. Okay. They returns double numbers, doubles number, right? Double its number, right? And after that, say whatever double, I am going to the sum it. So you can what the result double it, you pass it, and you can get some value, right? Sum it, and you can say done it. Okay. This is the single symbol main application doing all the thing, right? Main is going to generate number, double them, and then sum them, and then print it. There is no problem, right? It's the test it, right? But I want to know this is the separate work. This is the separate work. Here, for example, very simple work. Might be here it will take generate millions number. It will take some time, right? So notice generate number, double it, all work done by main thread, main thread, main thread. That is all activities completed by only main thread, right? So only one person doing the all work, right? It's clear output right here. Generate number by main work, double it by main thread, sum it by main thread. So all
Right.
these work sequentially done by our main thread, right?
Right.
So now this is the good for sequential programming. It's good. What happened? Let's keep this number activity takes some time. Let's keep duration thread dot sleep. So might be you can assume okay, this will take some time, right? So our main is waiting to generating number, right? Again,
Right.
main is waiting to double it. Even main is going to do, right? So why not this activity? I say, hey, this activity done by the person one, this is person two, this is person three, right?
Right.
So in this case, I am going to say completed future, help us here, completable future, dot say dot supply async. Here first time you want to call this method. Okay. So here say just use the lambda expression supplier interface, call any method, right? Okay.
Right.
After that you can say, after that again I am to do something. Let's say do. So say, hey, whatever the result you have, okay, result you have, I am going to call another method, double it, okay, double it and pass your result, okay, maybe double result double. Okay. Variable name can give you anything here, right? Double it, and after then again say, then you have to sum it. So whatever the here you can say generated number. Result is the result number. Okay. Here I found result numbers, right? First, result numbers I pass here. They do double it. So result double it, right? Double it, and you can say, hey, I'm going to call this summit. Summit, and you can pass the hey double it and take here as a summit, right? And after that, you can say, after that, I'm going to print them. Then you have going to consume is accept output, right? So final result, and you can say just s out dot out dot printed and result. Okay. Here, same thing. You are just going to divide them and say, hey, completed voucher, this is my set of works. Can you go with the separate, right? And once whatever the output pass here, whatever output pass to this thread, and finally give me the result, right?
Okay. So then apply means you're passing.
You are just thinking, hey, go to the separate thread done work, then
Mm.
apply separate thread one, and after that here say, finally I'm going to printing. Accept means just printing, and here the chaining can be number of business. Here our three level of business logic you are using three. Depend upon the business logic what you're going to do, right?
Mm.
Let's start it. So let's notice here the one tenant, here also one tenant output. But
Mm.
notice
Right.
here this generate method done by main, but here generate method done by your different pool of thread, right?
Right.
Double it done by the different pool of thread. And notice here sum it done by the main thread, right? So
Right.
here thread pool say this say ki whatever the thread available for me, I am going to reuse them, right? So
Right.
here this all work done by the separate threads, and even you can pass your own thread here. Yeah, I want to this a specific thread do the work, right? So you can pass second parameter as a executor framework. This is the new thread pool. You can pass second parameter right here. But here explanation is that ki whatever the things here now doing now done by the separate thread.
Okay.
Here
Separate
only
thread.
main thread doing all the things, right?
Mm. Right.
That's out. So generally, all notice here now same code you are adding sequential thread, and now notice the same code I written in multi-threaded environment, just sample specific method. There is no change in the code. Notice no thread, no start, no runnable, no implement. Notice
Right.
the completable features a simple way you can complete your business logic in multi-threaded environment, right?
So we can use this the
Yes,
completable future on any scenario.
right. You can use, yes. So notice here main thread is doing one by one all the tasks, and after that this executor frame doing the same different work done, and they return the output, right?
Mhm.
Even you can say output return by the also which thread, okay? Uh, by just thread name, right? Thread dot current thread dot get name, right?
Right.
By, and here when you say key output by, so output also print by, yes, say output print by which thread, right? Output print by which thread, right? Here always because the main thread doing, so always main thread printing, right?
Right.
Here might be main thread, might be worker thread, whatever the completable feature say, ki I am just going to reuse the number of threads. If already exists some threads free, I am going to use. If no thread free, I can start new thread. So notice here, generate number by thread 1, double it, thread 1, summary, and output also with double thread, right? Here. And notice first here, all done with the main work, right?
Right.
So thread pool internally generate pool for you. The completer feature also is by default thread pool, and they depend upon the available threads. They are requesting, hey thread, you can do your work. Whatever your output, just I am going to start new thread and pass your input to here, right? Once you done, I do request to the new thread do it, and new thread do it, right? So
Right.
here, like the same sequential code, whatever written can be converted into multi-threading very simple way using the completable feature.
Now, where does this number getting from? Can you explain?
Yes.
48, 49, and 50.
So
Line
notice
four,
here output. How, again, ask question. I forget. What is the question?
yeah, line 48, 49, and
Uh,
50.
uh. So this is the I just written the code. This the method they generate 10 number.
Right.
Just let print the output, right?
Right.
Good option. This is the 10 number I generated. Here say let's say in the variable, right?
Oh, so you just send the numbers to
Uh,
list.
Just, just here. Here might we can call database, call microservice, get all the numbers. What? Here
Mm.
I can just generated number. Okay, generated uh, num list equal to s list. Okay. So here I'm just printing this list as well as right. Keyword the list returning. Which thread returning, right? The generate method just I dummy generated 10 number 1 to 10, right? You can generate any number, right?
Right.
So now I'm getting two times generate and generate list. So notice first time main method generate this list 1 to 10 number. Okay,
Right.
and you double it, and I can and here this is the generate method called by this my worker thread pool, right? They generating the same 10 number, right?
Right.
And you double it and sum it. So even you can simply print here the whatever the output I'm here showing. Say let's just in a variable, right? Directly not print, just get in a variable, right?
Right.
Variable and just say return whatever, and here simply say print the value because you should check this double it method and what the list they double it, right? This is the list one, okay? So here double it. Similarly, sum is the same number we are printing. So let's also you can do it in the variable. Okay, for just printing, right? Some return some. Okay, and here say, so this is the submit call, and this is the sum. Finally, what sum returning, right? In this way, you can also write all the output. You can look the semicolon, right? And now run it. So here you can define your business logics and just framework infrastructure help us. You can and observe that main started to call generate method generating 10 number, and after that double it done by the main, all the number notice double it, right? And after that you sum is in same period with the all activity done by initial is a sequential programming by main thread. Notice main all, right? Now come in the computer pool. So I started generate number, they generating number by the thread pool, and again double it by main thread. Notice here main thread, and again double it main. Why? Because till now main is a free, right? To do
Right.
work.
Right.
So thread pool can use any number of thread, whatever the available they have. This is not guarantee always thread pool one do. If you run, sometime give different thread doing work because they have intelligence. Notice in this time, generate number by thread pool, double it also by thread pool, and sum it also by thread pool, but output print by main thread, right?
Are
So
this
here,
virtual thread or actual thread?
no, it is the actual thread. All are the actual thread.
Actual thread. Okay.
Till now, I'm not explain about the virtual thread, but we're going to talk all
Right.
about
Right.
this is operating system thread, OS thread,
Right.
platform thread, you can say, right?
Yeah.
So now writing multi-threading code is not so complicated. If you are here, you're not writing new thread, start, implement, runnable, callable. You're not doing
Nothing
anything,
like
right?
that.
Just I'm saying this is my method. Call from specific inside this block. Just result pass here. So these are the very simplest way you can write your code in the multi-threaded environment,
Yeah. Right.
right? And any code, whatever the your method here, this method take a let's you want to average it. So might be average it need a two kind of a let's keep same one more one method take a two input parameter, right? Or
Right.
three parameter, you will do it, right? So because here inside a method you can call any method, pass two parameter, three parameter, four parameter, whatever you have, right?
Right.
So, in short, completable future now help us in Java. Any method, any code you can run in the separate thread, and even you can associate get result as well as without any blocking call. Right? You're not here. Main is not waiting. Main is doing his own work. Just started. Hey, you do your work, right?
Right.
Here depend upon your number of method business case different thread going to started by thread pool and executing your work, and finally chaining of threads also done by internally here. You don't worry, you don't wait ki, how I'm getting the result like future.get, you don't do, right?
Right.
So till now any confusion with the completable future is the one of way where you can request Java virtual machine, hey, this is the method I want to run in separate thread. This is the method I want to run a separate code. Yeah, this is the code. Yeah, this is the program I want to run separate thread.
Right.
They are doing for you.
Right.
Is it good?
Yeah. It's good. Now I understand.
Here example can be here like generate number. Might be here our example. I can say, hey, call microservice, get a user profile, right?
Right.
In this method, you are once you get the user profile and call this second method. Hey, this is the user profile. Now you get the user details from the bank, right?
Right.
Now you get the user profile blank. Let's call to the same user profile to, hey, this is the bank information. Can you verify the income tax department? This is validated. All the taxes are paid, not right?
Right.
All the pays. Then say yes. Generate notice. Maybe some fault or maybe correct. Maybe this person is okay. No notice generate. This person is a faulty. Generate notice for the particular customer, right?
Right. Right.
Any use case you can implement here. where you need some request response kind of thing, right?
Right.
First, I'm getting user profile. Then you are checking the bank detail for that user. From bank transaction, you figure out the proper properly taxes are pay or not, and then decide कि I generate notice for customer or not, right?
Right.
Even you can do with a single threaded application, it's good. But single threaded application is taking some time, because let's user profile getting microservice called take some minute times, right? 1 minute or 2 minutes. Your thread is just waiting, right?
Right.
Similarly, might be it will take some time. It will take some time. So our main purpose of multi-threading is on going to meet two objectives. One, the application performance. Second, is resource utilization. Why our main thread is just waiting? They are not doing anything. But our computer have lots of other work. Why cannot doing, right?
Right.
So multi-threading help us to see our resource utilization, means your CPU utilizations, and also in the same time you can get the performance increment, better performance, right?
Right.
So there is no harm you can write sequential programming or asynchronous programming. Both are the good, but depend upon the case, situation, your quick response time. Nowadays, each and everyone want your quick response, right? Don't someone want to anyone wait, right?
Right.
So completable future say, hey, I am not going to any kind of waiting concept. I am just non-blocking asynchronous programming model. So computer future say, computer future say non-blocking asynchronous programming, async programming model, right? We already know synchronous programming, asynchronous programming. Means ki here multiple thread going on, even both threads are not to waiting to each other, right? This is the
Right.
non-block asynchronous programming model supported by this completable future, right?
Right.
Similar kind of things in the completable future, lots of other framework, other utility, other library available in the market. Okay, some other programming language using, but Java also given someone really want, they can use this completable future. They are support non-blocking asynchronous programming model. Clear means non-blocking means our threads, these threads are not waiting for response, right? Say ki
Right.
I just started one thread and your responsibility you have to complete all the business logic. They completed something, they have to call another things that you can do yourself, right? And you do something and you call another one. You do something. My responsibility just I started one thread, you complete the business logic as the business design, right? I'm
Right.
not waiting for each and every one in this model, second model. This is the multi-threading model. Thread 1, thread 2, thread 3. Main started one, get the response, right? Again started, get the response. Again started, get the response. Then say business logic done. This is the blocking model, multi-threading with a blocking call. We are waiting for response, right? Here say multi-threading, non-blocking. You do internally whatever you have, right? So here also, three thread is started by four thread. Here also main thread, one, two, three. But channel communication different, right?
Right.
So due to that, say कि completable future support non-blocking asynchronous model. So whatever sometimes say asynchronous programming or multi-threading or concurrency, almost same time. Don't confuse, right?
Right.
So any question?
So async, what else are the same?
Uh, you can say synchronous programming, multi-threading, or you can say concurrency. All are the almost kind of similar thing. Say
Hmm.
synchronous programming model, or you can say multi-threading. Okay? or you can say concurrency, okay? Concurrency programming model. Almost all are kind of same synonym, you can say.
Right.
Here, non-blocking depend upon the use case. You are waiting or non-waiting. In this all case, maybe waiting, non-waiting depend upon the right what the written code, right? Sometime you want to wait. You have to blocking call or non-blocking. So this is the two kind of communication: blocking call or non-blocking, right? Here, thread call can be non-blocking or blocking. Okay,
Right.
right? Non-blocking or blocking. It's
Right.
clear what is the non-blocking blocking means? Non-blocking means just I'm not waiting for your response. I'm doing my own work. But here I'm calling and waiting for your response, right?
Okay.
Here
So far,
call
what we have
non-blocking.
done in the past is blocking.
Yes, is a blocking. The get method here. Notice here I started thread, but I want to get the result. Then I can't get method. Get is the blocking call. Your
Hmm.
thread is waiting for response. This is
Right.
the means
Right.
your current thread is waiting, other thread responds me, right? This is the blocking call. Means you are blocked for some period of time. You are not doing anything, just waiting, right? So here
Okay.
meaning blocking means on waiting for response.
Right. So
This
that's called blocking. You're waiting for
blocking.
a response.
This is no waiting for response.
Mhm.
For response. To own work. Okay. Continue to our
Right.
continue our work. Own work. Okay. This is the problem. Here, our resources are doing our work. Means your resource utilization going on, CPU using, right? But here,
Right.
our resources are not just waiting,
Right.
just waiting for response, not doing anything. Just, just waiting for response, not doing anything. Right? Right.
Got it.
So this is the meaning of. So this is the kind of terminology. Sometime, if you going to read the tutorial online, so these are the con- many time confusion words you can listen, right?
Right.
Okay. So hope it's clear. So today completed feature support non-blocking asynchronous programming model. Means asynchronous is multi-threading. All the multi-threadings are not waiting to each other, right?
Right.
Till before, whatever we did, are the blocking or non-blocking. Means ki whatever you're doing from this runnable interface, always non-blocking because they are not returning any value, right?
Right.
Only block happen if you want to result something. This callable interface. The call whenever you're going to implement programming, the callable interface means you are expecting some value. That means you have to waiting. Waiting means
Right.
blocking. So by default, due to that, this runnable is many times very famous because they are not blocking call. Just each thread running independently. I'm not waiting for your response or anything, right?
Right.
Still, due to they are very famous. But whenever sometime business say no, I need some response, then the problem come blocking call and non-blocking, right? So that is the theory. Okay, good. And
Yeah.
some example. So now using the completable future, any number of method, any code you can run in this multiple thread. Very simple way, right?
Right.
And couple of more classes we are going to understand some different use case scenario where completable future given some more method. Today we understand only the supply async and then apply and then accept, right? Right?
Right.
It's good for the day, I think. If you don't have any question.
Yeah. Yeah. That's that's a good content.
Thank you.
Yeah.